This is 8.4, quadratic functions and vertical motion. You may want to pause and get a chance to take notes on this. But we have an equation that you need to follow. This is the model that you're going to be following right here. And so this is the vertical motion model. And so let me explain each part of this. So first of all, the H represents the height of the object after t seconds after it is launched. So literally, like I gave you two illustration pictures. So you have a girl throwing a ball to the dog, and so literally, 1 second, 2 seconds, 3 seconds. The ball is literally going from one place to the next. Okay, so it literally keeps going until the dog jumps up and catches the ball. So 1 second later, or 1.1, or 1.2 seconds, 1.3 seconds. So the T is how many T represents how many seconds or part of a second after it leaves. And then the H is the height of the object. So I want to know how far did this girl throw it. She first started it at 6 feet high, and then how high did it go to be able to do that. So that's what the height represents. Now the VO, this right here, is the initial vertical velocity. So we know we can throw a ball at a certain speed, we can throw it faster, we can throw it slower, we can shoot a cannon or shoot a gun at a very fast velocity. This diving board, he jumps off at a certain speed. So the vertical velocity is how fast that the object is being thrown or launched or jump or whatever it is. And then the HO right here is the initial height. So for instance, again, this girl, the ball left from 6 feet high. This diving board, the guy is starting at a 30-foot cliff. So that's the initial height. So you could see this equation on this problem. They will tell you what the speed is, the vertical velocity, and they'll tell you what that is. And so you just substitute that in for the VO. And then the H, the initial height, is 30 feet, because again, that's the height that the guy is leaving the diving board off. So I set up the vertical motion model from using the model right here. I set this up using the information. So let's look at another one. So again, the rocket is launched from a 53-foot cliff. So again, it's starting off of a 53-foot cliff. And then the initial vertical velocity is 94. So again, I put 94 for the initial vertical velocity, and I put 53 for the initial height. So again, go back to the formula, and you can see that the initial height, see, this is the initial height, so that's 53. And then the vertical velocity is I put 94 right in the middle right here. So I'm just following the formula that I was given. So it says graph the equation to find out how long after the rocket is launched it will hit the ground. I also want to know how high the rocket launched. It doesn't say it in the written directions, but that's something that we're going to always look at, is how high the object went. So again, if you go to y equals, you plug this function in, and then you push graph, you can see a couple things. First of all, you can't really see the very height of the rocket right now, because remember our calculator, by default, it goes 10 in this direction, negative 10 over here, 10 in this direction, and negative 10 down here. So what we want to do is the object is being thrown or shot, it's a rocket, so it's being shot from a 53-foot cliff, and it's going to go a certain height. So what we want to do is we want to change the height so we can see the tallest part of this rocket being launched. So if you go to Window, you want to change the Y maximum to a higher number than 10. And it's kind of a guessing game. You don't really know how high it goes right now. So I'm just going to plug in 100 and then push graph again. And I still can't see the highest part of the problem. So I'm going to go back to Window and I'm going to change it to 200. And again, it's kind of, like I said, a guessing game, or you take an educated guess. So what we can do is we can see the rocket being launched, and what we can see the height of it now, and it's right there, and we're going to find that height. But it's landing 1, 2, 3, 4, 5, 6, 6.3, 6.4 seconds later. So it's literally, let me draw a picture. If we had to graph this, so notice the rocket is being launched at like a 53 foot. And it's being launched, and it's going to end up right around here. And if you notice, just by looking at it, just by estimating, right around 3 is going to be the height of it. And we know it's slightly less than 200. So I'm just drawing a rough graph right now. We can be more accurate here in a minute. Okay, so it's going to look something like that. All right, so again, the rocket is being launched from right here. It goes to a certain height, and then it starts falling down, and it's going to land approximately there. So that's pretty close to graph. Now let's find out a couple things. Let's first find out how tall does it go. Well, remember last week we started talking about the middle of the parabola, the axis of symmetry can be found by negative b over 2a. So if we plug this in, negative 94 over 2 times negative 16, and let's calculate that. So negative 94 divided by negative 32. And so this is 2.9375. So 2.9375, very close to 3, is the axis of symmetry. Very close to it. And so that's the middle of the parabola. So something I want to show you as well, if you go to your table, so this counts by seconds, 1 second, 2 seconds, 3 seconds, 4, 5, 6, and then notice what happens at 7 seconds. It's like literally below ground. So at 0 seconds, we already knew this, it's starting at 53 feet off the ground. At 1 second, it's 131 feet. So literally at 1 second, it's about 131 feet. So my graph's about right. It's about 1 second, 131 feet. At 2 seconds, it's 177 feet off the ground. So again, my rocket is pretty accurate. At 3 seconds, it's 191. So literally at 191 is right here. Remember, it's slightly before 3 seconds. Slightly before 3 seconds is the very tallest of it. What we want to do is find the very tallest point right there. And we're going to find that in a minute. So let's keep analyzing this though. So at 4 seconds, it's 173. Again, that's about right. 5 seconds, it's 123. Yep, my graph looking good. 6 seconds, it's 41 seconds. It's a little high. My graph's a little off right there, but it's supposed to be about right here, 41 seconds. So my parabola's a little off. And again, we don't know the exact where it lands at. Now, something you could do, if you go to table set, let's say I wanted to start at 6 seconds, but I'm going to change it to count. I'm going to change it to count by 0.1. So what I'm trying to find is at 6 seconds, we know it's 41 feet off the ground. At 6.1, it's 31 feet. At 6.2 seconds, it's still 20 feet above the ground. At 6.3, it's 10 feet off the ground. At 6.4 seconds, it's actually slightly below ground. And again, in real life, it doesn't go below ground, but according to the calculator, it does. So notice about 6.4 seconds. So this is about 6.4 seconds is where it hits the ground. That's the closest estimate using our calculator, what we can find. I'm going to show you how to find that the exact way in a moment. But approximately 6.4 seconds later, it lands. So something I want to do is a couple ways we can do this. What I want to do, if you look at your XY chart, what we want to do is plug in 2.9375. And when we plug that in, that's going to get me my vertex. All right, because we want to find the very tallest that it does. So there's 2 ways we could do this. One way we could do is just simply, we could go back to this and literally just plug in 2.9375. We're going to plug it into each one of these x's. So we could literally just use our calculator, negative 16 times 2.9375, close your parentheses squared, plus 94, close your parentheses, or open your parentheses, 2.9375, and then plus 53. So we could plug it into the calculator and then get our answer. All right, so 191, I know it's a 191. So I have my highlighter on. So I know this is 191. I still have yellow. We go to blue. So 191 and let's just round it to the nearest tenth place, 191.1 feet off the ground. So that literally is how tall, this is the maximum value of 191.1 feet. That's how tall that rocket launched, is 191.9 feet, 0.1 feet. And the other way we could have done this, if you go to your table set and just tell it to start at 2.9375. This is the way I would have done it. We've just done this, and we can see that it's 191.06. So if I ask you to do it to the nearest hundredths place, that's what I would have, is at 191.06 feet. And again, that would be the tallest that it goes. After 2.9375 seconds, it hits the highest mark. Because you can see that it's actually climbing, it starts going back down. It's lower and lower and lower after that. And again, I'm counting by 0.1 to be able to do that. Now, another way to do this is if you look at your graph, what we also could do is we could just literally go to second trace, and what we're going to do is find the maximum value. So this is another way to use our calculator, and it's going to ask you, see this question right here, left bound? So what we're going to do is we're going to move the cursor to approximately where the vertex is, the highest point, and then it says left bound. So what we're going to do is we're just going to go to the left of that. I just literally push the left arrow about 3 times, and I'm going to push enter, and then it's going to say right bound, and then I'm going to go back to the vertex, and then I'm going to hit enter about 3 or 4 times, and see to the right of it, I'm going to press enter, and then I'm going to go back to where I think the vertex is, and it says guess where it is. I'm going to guess. So again, this is a good way to find it. So notice that's exactly my answer that I have up here, 2.9375, and then 191. Now, to find the other thing, what I want to do is find out where it hits the ground. All right, and we're going to use this. This is we're going to go to, if you go back to second trace, what we want to do is find the 0. Remember, it's called zeros or roots. So we're going to hit 0, and then we're going to go literally to, we want to find out where it hits. So there's about where it hits, so we're going to go left bound. So I'm just going to go 1 space to the left, and I'm going to press enter. I'm going to go back to where I think it hits, and then I'm going to go 1 to the right of that. Now we can't see the cursor right now, and we could change the settings if we wanted to, but I know the cursor is to the right of it because I pushed the right arrow button. I'm going to press enter, and then I'm going to go back and press guess, right where the 0 is. And notice, so 6.390, notice it says 0 right here. So 6.39, so I was actually pretty close right here. So if I wanted this to the nearest hundredths place, this would be 6.390, and that literally is my 0, or my root, or my x-intercept, to better do that. So again, I graphed the equation, I found out how long the rocket is launched, will it hit the ground, 6.39 seconds, and I actually found the maximum value as well, how tall that it, how high the rocket went, and after how many seconds did it take to get there. So all that information is necessary to be able to find this stuff. So that's quadratic equations, and we use our calculator a lot.